All right, moving on to section 1.7, where we're going to have applications of simplifying polynomials. After this lesson, you should be able to add and subtract polynomial expressions, and you should also be able to set up an expression to represent an application problem. So let's take a look at example number 1. So we had a student subtracting two polynomials, and you see that student's work on this little sheet right here, and see if you can identify the error that the student made and make the correction. Give some time to do that, and you can check your answers here in a minute. Okay, so you can see as we try to combine like terms, right? Again, we saw that the student definitely properly distributed negative through the parentheses, right? We're adding the opposite, right? Where the mistake was in terms of combining like terms. 2x squared and a negative x squared gives us a 1x squared, but not sure where the student got this 8x, because we got a 5x and no other x terms in there. Okay, looks like we kind of mixed together this 5x with this 3 to probably get 8. Okay, so with these next two examples, we're dealing with the concept of perimeter again. Example number 2 is asking us to find the perimeter of the square. Well, again, we know the qualities of a square and that all four sides are the same length. Again, that's what these tick marks are indicating to us, that all four sides of this figure is the same length. Okay, but they only give us an expression for one of the sides. But again, knowing the fact that a square has all four sides the exact same length, right, we know that this expression can be applied to the other three sides. Okay, so now again, we can write this as an addition problem, right? Taking 7r plus 2 and adding it to itself, right, a total of 4 times. Or again, using that quick addition, we can use multiplication by saying, okay, I want 4 times that one side. All right, so I've got a much quicker and efficient way of getting what we need here, which is the perimeter, which is us adding 7r plus 2 4 different times. Again, repeated addition is multiplication. Okay. Example number 3, we're given the perimeter of that triangle is this expression, and we want to try to find this missing side. Okay, so again, we know that the perimeter, right, is all of these three sides added up together. So therefore, to find the length of the missing side, we're going to start with that large value, and this, which represents the perimeter, and then we're going to subtract the other two sides. So we're going to subtract 2x squared minus 9, and then we're also going to subtract 3x plus 4. All right. So again, we're taking this perimeter value and we are subtracting the other two sides. And what is left will be an expression for that third side. All right, so when we simplify and combine like terms, we should end up with x squared minus 5x for our length of the missing side. So again, here we are multiplying and dividing exponential expressions where the exponents are algebraic expressions themselves. So again, let's take some time to see if we can apply what we've learned in previous lessons to more recent lessons to find the simplified expression for these two. Okay, so for part A, when we are multiplying same base, the rule is we keep the base and we add the exponents, right? When we're multiplying same base, we keep that base and we add the exponents. So here again, the exponents are algebraic expressions, so that means we are combining like terms to get our new exponent for this base. Part B, we are doing a division. It's a quotient, so we're using the quotient rule, which means we're going to keep the base and we're going to subtract top minus bottom exponent. That's the rule that we learned earlier in this unit, that when we're dividing same base, we're going to keep the base for our answer and we're going to subtract top minus bottom exponent. Okay, so again here for that calculation, we are subtracting polynomials, which means we're going to distribute or add the opposite. And when we do that, we get y to the negative 2m exponent. And we can go one step further because this exponent is negative. We're going to take the base and flip into the reciprocal. And the exponent to that y base is going to become positive. Example number 5 says the diagram shows one rectangle inside another. What is the difference in the perimeters of the two rectangles? Okay, so again, we're trying to find the difference, so that means we're going to be doing some subtraction here, right? So when we are subtracting the perimeter of the big rectangle minus the perimeter of the smaller rectangle. Okay, so again, these are rectangles. So again, let me give you some time to see if you can figure this out on your own. So we are looking for the perimeter of the big rectangle, and then we're going to subtract from it the perimeter of the smaller rectangle. So in the first set of grouping symbols in these brackets, this represents the perimeter of the bigger rectangle. So again, because this is a rectangle, we know that it's going to have two sides the exact same length. So while this side is 4x plus 3, I know that this side has the exact same measurement. So that's why I did 2 times 4x plus 3. Same thing with the other two sides of that rectangle. I'm going to go ahead and double that 2x plus 1 measurement because I know that I have 2 of those. Okay, so here's an expression that we can simplify to find the perimeter of the bigger rectangle. We're going to do the same thing for the smaller rectangle. I'm going to be 2 times this measurement because I got 2 sides that same measurement, and 2 times this smaller measurement of x plus 2. And adding those together, that's going to give us the perimeter of the smaller rectangle. Okay, so let's go ahead and finish that off and see if you can get the same answer as I got here. All right, so when we simplify, so that means we're going to distribute. We're going to combine like terms. And because we're subtracting a polynomial, we're going to add the opposite, or we're going to distribute the negative. And then one last time, combining like terms to get the difference of the two perimeters of the rectangles. All right, I'm going to skip over to example number 7, where we have Farmer Bob is planting a garden in the spring. He wants to plant squash, pumpkins, corn, beans, and potatoes. His plan for the field layout in feet is shown in the figure below. It says use the figure and your knowledge of polynomials, perimeter, and area to answer the following questions. Okay, so again, let me give you some time to see if you can figure out the answers to these parts of example 7. Okay, so again, make sure that you are paying attention to the expressions that are written and what they represent in terms of this figure. All right, so part A is asking us to find an expression that represents the length of the south side of the field. So the south side of the field is going to be this part right here. So that means we're taking every one of those expressions and that we're going to add them together. So we're combining like terms to get an expression that represents the length of that south side of the field. Part B says write an expression that represents the length of the east side of the field. East side, so that's this side right here. So all of that right here represents the length of these two parts of the east side. So those are the expressions that we're going to add together. Now we need to be careful because we see that one of the terms has an xy, right? So again, we cannot combine that with the x term in this expression. So we're going to leave our answer like this, right? Because again, these are not like terms. I cannot combine those together. Okay. All right. Let me give you a little bit more time to see if you can figure out part C. It says write an expression that represents the perimeter of the cornfield. So how this is different is that now we're looking for, right, the measurement of all of this. And so we're adding all of this up. Right? Perimeter of the cornfield. Okay, so now when it comes to finding the perimeter of this cornfield, we need to find the lengths of all these sides. Now again, all of them are going to be expressions, right? So let's start off with this length right in here. Now we don't see anything written immediately on this side. Okay, however, if we look around, we can see that, right, this side is a side of what we can figure is this big, giant rectangle shape. Right? And again, us knowing that this is a rectangle, we know that, hey, this side here that has nothing written on it is going to be the same length as the side directly opposite it. And here we do have expressions to represent the length of that side. Got a 4x and a 5x minus 2. So that's where I have this, adding those up to find the length of this side. All right, moving our way around here. So we don't find the length of this. Well, that's given. That's x squared minus 9. So here I have x squared minus 9. I'm adding to my previous findings. And then you see here I have this plus 6x. Okay, where did that come from? Well, take a look at the diagram for the cornfield. It's this side. Got 6x. Now the next side I have here is this. The length of this side. Again, nothing written immediately on that figure. But again, if we widen our scope a little bit, we see, hey, that is a side of what looks like to be another rectangle. Or again, this side right here is going to be the same length as the side opposite it. So that would be this xy plus 1. So that's where I have this. So now the only thing we haven't found yet is the length of this side. This little piece right in here. Okay. Well, actually, I do need one more side. I think this one right here. Okay, so again, this side right here is going to be opposite this side of 6 plus x. So we got that side. So we still need actually this side right here. All right, so now here is where we're going to be a little bit creative. The way that we're going to find this side, right, again, you see that this side is part of this longer side for this rectangle. So the way we're going to find that is that we're going to take the length of this full side, which would be this expression right in here, and then we're going to subtract the length of this, which we look over here, is y minus 1. So that's what this expression here is all about. This is going to help us determine this little side piece right in here. Okay, so you can see there's a lot that we need to kind of sift through and simplify and combine like terms. So again, let's go ahead and do that. All right, so once all is said and done, we should get 2x squared plus 9x plus 7.